Okay, hello everybody. Hope you can hear us and see us fine. Thank you for joining the Open Science Clinic, jointly organized by the Foster Project. I hope you can hear us and see us fine. Thank you for joining the Open Science Clinic, jointly organized by the Foster Project. I hope you can hear us. And a little bit of a technical problem there. Thank you for joining us. The clinic is organized jointly by the Marie Curie Association, the Foster Project, and the EuroScientist. And I'll quickly brief you through why and how we're running this, and introduce you to some of the participants, co-organizers, and panelists for today. So, see if we can quickly plug ourselves in. Apologies for the delay. Okay, we're back in action. Hopefully you can see the slides. Why are we here today? Thank you for participating. I just want to do a round around the proverbial table, if you like, starting with you, the attendees. The last time that we did count on how many showed interest, these are the rough statistics of your interest. So thank you very much. There's great coverage, geographically speaking, but also in terms of representation of the research community. And it's great to see so many senior researchers and young researchers together making up more than half of the interest. We also have a lot of administrative support present, but most importantly, a lot of young researchers who are the key target group for this type of training. So why are we doing what we're doing today? Well, just a brief introduction. More and more young researchers are asked to transfer their science, their research, their results and outputs outside of the academic sphere and to society, whether that is markets, policy, private companies and sector, or if you like, a more colorful target, the global sustainable goals. So how does one do that on a regular basis, and how does one do that successfully and effectively? So one of many potential ways is to look at it through three simple steps. In order to empower yourself, the impact of your research, the societal impact of your research, society and the groups that you target, first of all, need to have basic access to your research. And that is still not the case. On average, depending on which discipline you're in, only 1 out of the 2 papers that you published lately are actually accessible to target groups beyond academia. So access is important. If there is no access, any proactive transfer of your research results is hampered, and it's not what it could be, it's not optimal. And one other skill that one can add to that is the translation, communication of your science and of your results in societal context, so that there is awareness among the public and the potential users of your results. So that's kind of the bigger picture, the reasoning, if you like, why we're organizing this and why we're focusing on the first step, access to your science. Just to go more into the mechanics of what the Open Science Clinic is intending to do, usually we run these clinics when a call is announced. So in this case, we're targeting Marie Curie. Individual Fellowships. The call was announced a month ago, so we're a little bit late. Apologies for that. But hopefully we're still in good time for some of the advice to trickle in into your applications or the applicants that you happen to be advising. So what is the basic mechanics? First of all, it starts with some introduction, and we hope we have done that a little bit offline, pre-webinar. We circulated an introductory course. It's one of many. It's produced by the Foster Project, but there are a vast amount of resources out there that vary from very static self-learning to more interactive and entertaining short lessons, e-lessons, to explain what open science is and why should one care. The second step is very much this webinar. So we have invited some very different speakers from different backgrounds and disciplines to give you their point of view on why you, as a young scientist or support staff for young researchers, might want to care about open science. And it's going to be a short webinar, so we can't cover everything, but hopefully we'll whet our appetite to go to the next step. And the next step is really where the work gets done and the tire meets the road. And that's where the clinic is really most effective. Post this webinar, what we offer to the young Marie Curie applicants is almost a weekly opportunity to meet via Skype, and in 20-30 minutes, customize some of the advice that you're about to hear today to the particular proposal at hand. So we can actually go beyond the just generic advice of what should and could be done down to what are the particular solutions for that discipline and for that particular research idea. So the clinic will run between this webinar and the submission deadline, which is 12th of September, I believe. So a brief introduction to some of the friendly faces you see on this webinar. First of all, I want to introduce to you John Tennant, who falls very much into the young researcher category, and he's a paleontologist from Imperial College London, a very practicing and proactive open science advocate. He's also founder of the Preprints Paleo Archive, and he currently organizes over 100 contributors into an initiative which is called the Open Science MOOC, the massive online course that aims to really give you the ultimate reference point for what open science is and how you can introduce it into your research workflow. Next in line, I'm glad to introduce to you Gareth O'Neill, who is a PhD candidate and also in linguistics. And he's also the president of the European Council of Doctoral and Young Researchers. So he will give you his perspective, both from disciplinary point of view, but also in his role of representing you, the young researchers, at various fora. After that, I will step in with some basic mechanics on how you can put both John's and Gareth's advice to use in the actual Marie Curie application. What does the application demand, and how can you refer to John and Gareth's recommendations in a way that makes you win evaluation points? And we have been doing this experiment for 3 years now. So I can assure you that in very small and elegant ways, citing some of the resources that they will point you to, you can win a competitive edge in a very highly competitive instrument that is Marie Curie. Next up, unfortunately, we could not connect, but Rinske Vandenberg is an EC policy officer and very aware of what the funders care about in terms of young researchers' emerging skill sets. So she will be joining us via the chat, and she will chime through the chat. If you have any questions for the EC, please use the chat, and then at the end we can field it, some of them to her, and hopefully get a fresh answer. The last two ladies, yeah, we have Fernanda Bianca and Maya Misa. So we have a development biologist who's also the chair of the policy working group at the Marie Curie Alumni Association, and the archaeologist applying natural science methods to her research, also part of the Marie Curie Association, and they have been essential in bringing this webinar to you, as well as running a very popular series for Marie Curie Association. So that's the round of the table. So without further ado, I'd like to ask John Tennant to step up and give us his point of view on why he as a young researcher practices open science and why should young researchers care about it. John?
All right, thanks, Ivo. And hi, everyone. Thanks for joining us here. So my name's John. I'm a paleontologist, and I finished my PhD almost 2 years ago at Imperial College London. Now I'm sort of like a rogue researcher and spend a lot of my time discussing various aspects of open science while conducting my research. So for me, open science is like a way of doing science that helps to make the process much more transparent and rigorous. In reality, it involves quite a complex network of principles and practices. And really, most of us as individual researchers do some of these anyway, but we don't necessarily call it open science. For example, if you as a human being believe in principles like fairness and equality and inclusivity, then you already align yourself with the principles of open science and therefore should find it much easier to embed these principles into your actual research practices. In reality, again, no one has ever been harmed by practicing open science. Fears around things like scooping existed years before open access was even a thing. And you had researchers being assholes to other researchers before we had things like data sharing and open science. So a lot of the fears which people have about open science aren't really about open science. They're more fear about the general academic system itself. And if you look at how things are moving these ways, the opposite is quite true in many ways, in that almost everyone who supports and practices open science in some way or another are becoming these emerging leaders in their field. If you look in almost every research domain these days, the people who are championing or becoming champions of their field are those who are supporting and adopting open scientific practices. And they're already going on to inspire future generations. And it's quite incredible. So now I want to just quickly mention like some of the major aspects of open science and how they can be used to enhance your research and your research profile. Open access is probably the big one, which we know. One of my favorite quotes of all time is, "Open access wins all of the arguments all of the time." That was said by Ahmed Ogunlaja from Open Access Nigeria at the first OpenCon back in 2013 now. And he's still right. Open access, like at its core, means that anyone can read and reuse your work. This includes journalists, policymakers, even your parents, people who run startup companies, and really anyone who could be interested or find a reuse for your work. Paywalls prohibit this, like in the worst possible way. The increased exposure can only be good for your career, for you, and for your research itself. Now, a common argument against open access, which we hear from junior researchers quite a bit, is the cost. Often it is prohibitively high. And this is bad because it's just as discriminatory as a paywall. It's just on a different end of things. But in reality, again, there are always ways past it. If you look even at publishers like Elsevier, they allow you to publish the accepted peer-reviewed manuscript online upon acceptance for free. So before even Elsevier have published it and stick it behind their paywall, you have the opportunity to freely share it with the world. This is something which I feel a lot of people don't know because most Elsevier articles still remain behind paywalls. So this is what you can do is like have your open cake and eat it almost. Like you can stick with your journal of choice, not pay the high costs, let the publishers enjoy their little role in this, but still make your work open access for free. This sort of pattern is similar even for like the top or worst journals like Nature and Science, where all articles can be made freely available, open access, either immediately through preprints or after a 6-month embargo period for accepted manuscripts. This replicates itself across almost the entire scholarly publishing system. It is eminently feasible these days to make your work open access without cost, but the biggest barrier is becoming informed about these choices available to you. And what we do know as well is that open access helps to increase your, like I said, exposure, your ability to collaborate with researchers around the world. If citations and bean counting are your thing, it helps to improve your metrics as well. And all of these things help to enhance your personal academic profile in line with the aspects that you need to help advance your career. It's very similar as well for this re-emerging preprint landscape. So a preprint is a manuscript that is typically shared online as it undergoes the peer review process. If you look now around the world, you have research funders like the European Research Councils, Cancer Research UK, the NIH, the Wellcome Trust, HMRI, the EMBO Long-Term Fellowships, Human Frontiers Science Program, the Helmsley Trust, even Chan Zuckerberg, and the Simons Foundation. These are research funders which now all accept and encourage you to submit preprints in your grant applications for research funding there. And this is a rapidly evolving landscape where the increasing recognition of preprints is increasing. And this is fantastic because you can get more exposure for your research, get more citations, get your research out there more, and be rewarded for doing so. So there is no preprints can harm my career. Preprints can help you accelerate your career in this case. It's very similar, again, for things like data sharing. All available research out there shows that if you share your data openly, you probabilistically will get an increased frequency of citations. And in a time when citations is still one of the prime aspects of academic currency, this really matters. So while this should be the sort of secondary incentive for data sharing, for a lot of people, this incentive helps them encourage to be more open, which is itself fantastic. On the other hand, with data sharing, we should also be asking why the corollary exists. Like, why are some researchers not sharing their data? And this can be a very powerful question to ask your colleagues and friends. So, for example, why are they not sharing their data? What are they hiding, and what are they afraid of? Because we know that science works best when all available processes, practices, and outputs are open, so that we can inspect those intricacies and then contribute in a civil and open manner. This is how research works the best. And you simply cannot do this if everything is locked away. And as well as this, sharing data and open science in general helps to engender public trust in research. Like, is it any wonder why we have so many idiots saying that climate change isn't real? This whole vaccines cause autism rampage. And when we turn to face those people and say, well, haven't you seen the science? And all of that science is locked away, then is it any wonder why they don't trust us? So opening up the process and the outputs helps to engender public trust in research and help to combat some of these pseudo-scientific mindsets. Again, it's very similar for things like code sharing. Research in almost every field is becoming more computational and more digital. Again, all the research which looks at people or disciplines which have shared their code shows that by adopting open source practices, increases the reusability of your work and increases your citation counts. Ultimately, this allows others to build upon your work, and therefore you can receive more credit for more of your research rather than just a PDF. Sharing is absolutely key to collaboration in this respect, and collaboration is fantastic for advancing your career. If you're not open about your research, it prohibits reuse, which prohibits collaboration. And that means that basically you're the only person who can build upon your research, which slows down the progress of science. By being open, you accelerate the development of research in your field and open up new ways of collaborating that you haven't even thought of yet. In my experience, by being open about my research right from the beginning of my PhD, it's opened up this huge network now of global collaborations. And yeah, the opportunities are endless, but you don't know what they are if you are closed. So share your work smartly and effectively and maximize your impact. Ultimately, this is what we want. For example, now I work with a range of paleontologists around the world who I've never met in real life on various dinosaur-y and crocodile-y projects. Alongside that, I also work with librarians, publishers, researchers from all around the world and in every discipline imaginable to do with the future of scholarly communication. This is how I met Eva and Gareth, for example. And we do this through online collaborative platforms such as Overleaf for writing manuscripts, but also environments like GitHub, which are incredibly powerful for collaborative research. So to sort of like wrap all that up, like open science for me is about allowing an individual to demonstrate their worth, the commitment to the scientific endeavor, as well as the values which underpin their daily activities as a human. Now, often this can require a bit of a shift in your mindset, because as soon as we are introduced into academia, we're not being trained to be open scientists. We're trained to play into the system, to play the games. Every young researcher now knows about the publish or perish mindset, and we have to break that apart. Often openness doesn't even factor in like at the beginning of your training. But if you embed open scientific practices into your research right from the beginning, you don't even have to play this system or play these games, because you'll be so much better than it altogether. And ultimately, what you'll do is you'll learn amazing skills that will help you to excel in almost any modern research environment. And you will use these to accelerate yourself, your discipline, and your profile, ultimately. This is something which we're trying to build at the moment with the Open Science MOOC, which Ivo mentioned, together with organizations like Foster and Eurodoc, to sort of increase the adoption of these practices in a systematic way across graduate schools. Yeah, in a world in which publish or perish is still very much the core mentality, this probably isn't going to go away anytime soon, but you can sort of play that game and do one better at the same time. Ultimately, you'll get more attention for your work, accelerate your career, and do great things for science all at the same time. There is no divergence there. Similarly, if you don't want to stay in academia, by adopting all of these new practices and skills, you'll gain a lot of transferable knowledge, which you can use in many fields, in many industry and career paths away from academia, which is great, really. So it makes you more employable in a more diverse system. So just to sort of finish off, I understand that one of the biggest prohibitors for open science is this very real perception of risk. And often, as junior researchers, we exist within a system that makes us feel powerless. There are skewed power dynamics at play here. But what I want to tell you is that there is an enormous community out there who are more than happy to help you with these things and to help educate and train yourself and become empowered yourself, so that in these rapidly changing times, you can help become a leader to lead that change in your field. This is the way towards like the scientific revolution, which we're now currently in the midst of. And through all of this, I want us to be in a position where in 5 years' time, we look back and say, why didn't we always do it this way? That's it.
Great. So I just want to take from and build on something John said. Open science has many advantages for your career now, but it also requires a shift of mindset. And when we collectively do training for young researchers on open science, we frequently find that shift of mindset is rather significant. But I just want to plug in Gareth now and explore a little bit the question from the benefits of today. Where are we going in future? I mean, at the moment, young researchers are roughly evaluated on how much they publish and how much those papers are cited. Is this likely to remain like this in future? And do we have any indication that open science might play more of a role in tenure and in career progression for young researchers? Gareth?
Yes, so thanks for inviting me. This is, I think this is a great initiative from MSCA, Foster, and so forth, and everybody involved. Short answer is yes, I do think so. What I would say, and I'm going to focus specifically now on the policy side of this conversation. So perhaps why is open science needed? Very brief. What is exactly needed, and then what is the relevance for research careers? So maybe just to restate some of what John said on why open science is needed, and what's the relevance of it for the researchers. I mean, number one, it increases researcher visibility, it increases their impact. This is obviously a positive thing. It builds upon previous research results, and it improves quality of results. It encourages, as John said very clearly, it encourages collaboration between researchers. There's some great initiatives at the moment. And this, of course, improves results again and improves efficiency. It also speeds up innovation, getting research results into tangible, products or research results to the market. And that goes much faster, of course. And it makes a much more transparent environment for researchers and the tax-paying public, and it involves citizens, it involves society. So it opens up and it breaks down this, in my opinion, disappearing concept of the ivory tower. I don't think it exists anymore, or at least what's left of it is probably rubble. But that's a personal opinion. So what is needed for open science for researchers? I think the first thing to maybe describe is what exactly is open science. So we did a survey with the European Commission and with Eurodoc last year, and surprisingly, most researchers do not know what open science is. Generally speaking, they don't really know what it is, and specifically on both practices and policy initiatives, they're not really clear. They do have an idea of what open access is and what open data is, but after that, it kind of goes down to very low levels of awareness on what exactly these practices are. So just to maybe mention a couple, so it's clear to people what we're talking about. Open access has been mentioned, so open access to research publications. We have what's called open data, so opening up research data to anybody that wants it. It doesn't necessarily mean that it has to be fully open. The mantra is as open as possible, as closed as necessary. You can have levels of restriction, of course. And I think one of the best ways to summarize open data would be the FAIR principles. Data should be findable, accessible, interoperable, reusable. You should use metadata, and you should perhaps consider using data management plans if you're not already being mandated. And I'll come back to that in a moment. Some of the other practices, perhaps less well known, are open education, opening up materials to, for instance, students who want to learn, or to teachers who want to use others' materials and not reinvent the wheel. We have open evaluation. The main part of this would be open peer review, so opening up the actual peer review. There's a lot of good examples of this at the moment. We also have what's called alternative metrics, so how to assess researchers' impact and perhaps even careers, steering away from the impact factor and high impact, high visibility. We have open licensing, so when you create research, or even for an example, you create an image, have you got certain levels of sharing that you want people to use, and you let them know. And the famous one for this, of course, would be the Creative Commons licenses. There's quite a lot. Some of the others would be open methodology, so how you actually do your research. One part of this would be pre-registering your research plan, so how you're going to do it. So when you get the results, people can see that's actually what you set out to do, and not that you tweak it a little to fit your results. And one of the other ones would be open lab book, where you actually open up your laboratory notes to the public as you're doing your research. Two final ones would be open source. So open hardware, opening up, for instance, digital prints, blueprints of machines that need to be used in science. And John has mentioned GitHub, open software. So opening up the software code of research projects so that you can actually see how they did it. You can even copy it and use it yourself. The final one, which is getting a lot more traction at the moment, would be citizen science. So involving and engaging citizens in science. So when we talk about open science, we're talking about a whole framework of initiatives. But from now on, I'm pretty much going to focus on open access and open data, which is the main one. So what would I say is needed? The first thing that's needed is to raise awareness. Obviously, if a small majority of researchers know what open science is, we need to do a lot more. And initiatives like this webinar, or for instance, like the Open Science MOOC, which is gaining a lot of traction now, which John is leading, or the Foster Plus Open Science Project, which Evo is involved in, and Eurodoc. These are initiatives which are opening up, awareness to researchers of what open science is, how and why they can do it, but also more crucially, why universities and institutions should be doing it, because they themselves are also sometimes in an unsure position of what to do and how to implement it, particularly when it's not clear what open science is. The second thing, which John also mentioned, was to train researchers. So the first step is to make them aware of what it is. The next step is to actually help them do it. So you need to train them in the skills they need for open science. Eurodoc has the position that you should train them for, in any case, open access publishing, what it is, how to do it. Open data, so again, what it is, how to do it. Research integrity, which I will put under open science. So what that means, how to check if you're not sure, and what to do if you signal perhaps people who are breaching integrity or creating misconduct, and how to deal with this morally, ethically, and practically. Then the next thing I would say is that you start using initiatives that are already out there. I mean, we do not have to reinvent the wheel. As I said, there is the Open Science MOOC, which is currently being developed. If people are interested, sign up for it, get involved. You can actually help contribute. We have this, again, Foster Project, which is working on all the different aspects of open science. It's online. It's not fully finished, but there's already quite a lot available. You can go there, you can access it, you can learn about it. This is not enough, however. We also need to support the researchers at research performing organizations, at institutions. So there needs to be a help desk or a specialist, perhaps even both, at the institutions, where me as an unknowing early career researcher can go say, I want to do open science. How do I do it? What do I do? And then I can get actual help at my institution to do this. We also have guidelines. This is very mixed across Europe. When we did the survey, we asked, how many guidelines are you aware of? Very few people know that there are guidelines, even when they're there at institutions. And these guidelines essentially give you an idea of what the institution understands as open science and how you can do it, where you can go for information. Maybe a final point on the support is what are called data management plans. So within Horizon 2020, for instance, within the open research data pilot, many researchers they were mandated to actually create data management plans in their research. So you set up a plan. This basically says what research data you're going to collect, how you're going to collect it, what you're going to do with it, how you're going to curate it, and crucially, what are you going to do with it when you leave? Because of course, data needs to be somewhere, it needs to be hosted, it needs to be opened. So this sets out, even before you start your research, what you're going to do with it. And this is crucial because in many cases, people develop, they go through their research, they have results, and then they wonder, okay, how can I make this open? And this creates a lot of problems. The data may not be so openable, but also, for PhDs and postdocs, when their contracts finish, they finish. They don't have time to go back and then try and open up their data. So it must be included in there. And then just to say that in many cases, this is not mandated, but within Horizon 2020 and most likely within the next framework program, Horizon Europe, it will be mandated. Data management plans will most likely be mandated in all research projects within the framework program 9, and open access will most likely be mandated. And the former Director General, Robert John Smits of Research and Innovation at the European Commission, has just become Special Envoy on Open Access to the European Commission. And he has set a target to make all research publications in Europe open by 2020. Very positive, and all I think we can do is support him, in this role, and perhaps discuss the role of the publishers at a later stage. So maybe to move on then to the relevance for research careers. To be very honest right now, researchers are not being rewarded for open science, at least not from institutions. And this needs to change, and it is changing from a higher level. European Commission is moving towards this. And I think crucially, maybe two things is we are moving, and we should move away from bibliometric evaluation and this absolute pathological obsession on high impact journals and high impact publications and impact factors. So the quantification of research publications based on particular journals in some cases. Now, we move away from it. What should we move to, right? So I think we should be moving towards, and that's, I think most people would agree, certainly here, an open science friendly environment. So not just an environment that raises awareness, not just an environment that supports the researchers, but absolutely crucially, an environment that rewards us for doing this. So the institutions, the funders, and you can add a few more there, they need to start actually rewarding research careers for doing open science. So it's not enough to just do it. They should actually be including this in your career assessment, in your career evaluation. And open science should be playing a role in how you move forward and how you move to the next level, not just on how many journals you have published in or which ones you have published in, but crucially these other aspects. So one of the things that the European Commission has developed, and I believe it's still somewhat in development, is what's called the Open Science Career Assessment Matrix. I'll put some of these in the links later. For short, the OSCAM. And this sets out to create a new rewarding environment for research careers. So I can give a few examples of how this looks, and I will put the link to this later on. So what we have is, we have, like, you can imagine it as a whole scale of different open science practices which can be basically rewarded. So one of them would be what's called research output. So rewarding, for instance, research activity, so moving towards open science practices, publications which are in open access, that can be through self-archiving, or that can be in open access journals, opening up your data sets, your research results, opening up, like things I've mentioned, like open source funding. Not only this, you can move towards another category, which is the research process. So getting involved in stakeholder engagement or citizen science, collaborating in large projects, collaborating across fields, being interdisciplinary, actually implementing research integrity in your projects and showing that you're doing this. We have another category such as service and leadership. So not just doing open science, but actually being a leader, perhaps even being an advocate, as some people here do. Promote open science, give good examples, best practices, show how it's done. We also have, of course, open peer review, networking. I will add a couple of more categories to show how extensive this is. We have the research impact. So not just on publishing, but also the use of IPR, the use of, intellectual property rights, the use of open licensing. What is the societal impact of this? Are you communicating your research to the general public in an understandable way? Are you perhaps sharing research data on Twitter or social media? And then even other aspects of academia. So not just focusing only on the research, but actually on the teaching and supervision. So being rewarded for teaching, being rewarded for mentoring, being rewarded for supervising, and somehow involving open science in all of this. And perhaps the final thing then is actual career development, and putting again this under this huge umbrella of rewarding researchers for open science. So including open science in their professional development, including it in project management, including it in developing yourself as a researcher, and perhaps more crucially, which not many people discuss at the moment, is what is the relevance for open science to the non-academic labor market? Because clearly open science and industry do not always see eye to eye. However, that does not mean that industry is not open. Many big companies, I'll take Philips as an example, have open campuses where they get people to involve, collaborate, share data, and this is actually very, very productive for the research process. So yeah, I think I'm going to leave it there. I'm pretty sure there's going to be a lot of discussion, but maybe for me, the core points are to raise awareness on open science more, get people involved, get them interested, sharing it, doing it, getting the institutions to support them, getting this online materials together so that we can use them and help support them too. I do think we need to focus. We cannot do everything. So for now, perhaps we need to focus on open access, open data, and then you can pick research integrity, and then perhaps you can pick one of these other things, for example, citizen science. And I do think that, we are moving toward this. I think it's going to be several years before it's fully implemented, but all signs are that this is moving slowly ahead. And I think we need to push it a little bit more.
Great. Thank you, Gareth. I hope the two speakers are giving you plenty of food for thought. For the 189 attendees, do use the chat box if you have any questions, and we'll try and pick the most frequent ones at the end when there is time. Before I plug in one question now, which is pertinent to the two speakers, I just want to mention we did have plans to have Rinske Vandenberg from the European Commission. She's a policy officer there. And so in case she's listening, she promised to feed the comments through the chat box. One question that would be nice to have reflected from the Commission is this move away from just bibliometrics that Gareth mentioned, and also Jonah earlier. There is a lot of suggestions that the evaluation system is changing, that the algorithm by which you will be judged in future for tenure is changing, but we are not seeing anything yet. So the question to the Commission and Rinske is, can we point the attendees to examples of already funded running projects that are actually rewriting the assessment algorithm and criteria in a constructive way that's moving us constructively away from bibliometrics? And we do know that there are projects like this, but it'll be great to have the information from the source. While waiting for that, there is a question, and I'll put it to John Tennant. I think it's a great question that we come across frequently when we do training, and it goes like this. I'm an average researcher. I'm publishing 2 to 5 papers a year, and I do not have the funds to pay the author processing charges. how do I achieve 100% open access?
All right, so there are 4 ways to do this. The first is most open access journals operate on a fee waiver system. All you have to do is ask, and they will usually waive the fee if you can demonstrate need. The second one, as both me and Gareth have mentioned, is this self-archiving route, or green open access, where you can archive the author-accepted manuscript online, usually immediately upon acceptance of your paper. Sometimes there's an embargo too. The third is to interact with a co-author who does have funding. So, for example, work with someone in the UK where they have diverted millions of pounds of funding into funding open access. And if you get one of them as a co-author, then they can pay. And the fourth one is to use a venue which does not charge an APC. So if you look at the directory of open access journals and across the board, there are thousands and thousands of journals out there which give you gold open access without fee. Again, this is just simply knowing what options are available to you and exploiting them in a way that does not put you in risk.
Great, thanks, John. Another question came in, so the last one to Gareth before we move on, and then we'll come back again at the end with questions. One attendee is asking, should applicants include the open science metrics that you mentioned in their application? So what's your take on this?
Yeah, I interpret that question as should they include perhaps things they've done that align with some of those metrics. That's at least how I'll interpret that. So my answer would be absolutely. I mean, you don't need to give a washing list, but what I would do is for people who are engaged in open science, you know, and it's this whole list that I have given, they should take some core examples of what they have done. So I would look at this in 2 ways. I would add in such an application what I have done regarding open science, and what I'm going to do regarding open science. So what I have done regarding open science, you know, I would include, for instance, valorized projects. If you've been engaged in citizen science, if you've been engaged in science communication, if you have open access articles, state that clearly that these were in open access. You know, very often you need to add a CV. You can even put in your profile description that you fully support and believe open science if you do, and you can mention that there too. And that's being specific. I would like also to maybe go a bit generally on what you could add on things you will do regarding open science. So you know, there's 2 options here again. In some cases, you may not be obliged to add an open science element to it. In other cases, you might. For instance, in the Marie Curie Individual Fellow Program, it's mandatory to add a data management plan. There's certain criteria for this. But you actually have to already think in advance of the research data, what you're going to collect, how you're going to do it, what's going to happen to it, and you need to put that in a plan. And you're given, I've understood, a certain template that you can fill in, so you don't have to start from scratch. You can fill in, think about it, talk to your, you know, either supervisor or future supervisor, and talk together about what are we going to do in this project, how are we going to sort out our data. What I would say also is, if you're going to focus, I do think at the moment, because of the focus on open access and open data, that you should take those 2 things as the core for what you should add into your application. So you should say that you will attempt to publish in open access, like one of the 2 examples that John's given, so self-archiving or in an open access journal, whether it's paid or not. Of course, that comes down to your research budget. But what I would also say is that you focus on open data, not just on the data management plan, but also that you will use certain principles. You will follow the FAIR principles, perhaps a short summary of how you will follow those principles, and perhaps even give examples of, you know, how you will open up your data. If you plan on opening it up through science communication or citizen engagement, put that in there. It will be very clear you have a plan ahead, and I do believe that the MSCA will take that positively. As I said, we're trying to move towards open science, so every little step is appreciated. And what you can do is, you know, I focused on open access and open data, but you can actually consider some of the other options there as well. You may even be doing it. So you could consider, how can I make my project somewhat citizen sciencey? And I mean, it's not necessarily that you have to go and create a huge project and do this, but you could think ahead. How could I open this, even if it's just a small bit? Or you could say, if you're more into programming, I'm going to open up my data on open source, and I'm going to get the community involved in my field or even outside, and I'm going to use GitHub. You know, don't leave this implicit. Put it explicitly in the proposal, short, concrete, I've thought about this, and this is what I'd like to do. This is what I have done. So that would be my advice for the applications.
Absolutely, I couldn't echo that more. The general advice, if you like, from 3 years of experimenting, mostly with Marie Curie Individual Fellows and with the ITNs, is that you cannot go wrong by including more and more aspects of open science. We are yet to see an evaluation summary for a proposal that is very open science progressive and being penalized for it. One gets penalized for doing things badly, but never for being proactive on the issue. So thanks, Gareth. I see that from the Q&A box on the chat, there is a lot of appetite on data management plans. It is a skill in itself. It is a webinar in itself, so we can't spend more time on it today, but I strongly advise you, if you're interested, same time tomorrow. The European Open Science Cloud and the Open Air project have a specific webinar run by 2 of the data management plan gurus in the Netherlands. And they will be going through the nitty-gritty of research data management and the data management plan. So do follow up on that if you're interested. We can also run a follow-up webinar if there is enough appetite. But we have to move on. We are running a little bit late. The fun part of the webinar is over, if you like. What I'm about to show you for the next 10 minutes or so that are remaining, I have done a very dry exercise. I have taken the template of the Marie Curie application form that those of you applying will have to fill in. And I have tried to just pinpoint the obvious places where all of the conversation and advice you've heard in the last 50 minutes fits directly into the template. And it's not exhaustive. We could improve it, but time limited. And I am only cherry picking the cases where we have strict evidence that the evaluators positively comment on including these aspects into the application. So if the technology allows me, I'll switch back to the slides and see if we can go through this. Okay. So how is this relevant to your average Marie Curie application? For those of you that have applied before, it's the usual 3 sections. One has to focus on research excellence, and we can't generate ideas for you there, but we can definitely give you advice on how to improve your methods. Impact is the traditional area where openness adds a lot of points for applicants. It is also the traditional area where an average applicant loses a lot because it's difficult to deal with. There is no recipe book, and researchers that are very good at generating. Yes?
Ivo, just a minute. I think that we are not seeing what you want to show. It's not projecting.
Okay. Apologies for that. Let's see if we can do it again. Is it coming through now?
I'm seeing slide 7. It's not projecting. It's within the presentation.
Okay, so if we just blow this up. Are we good?
We are seeing it within the presentation, but that's fine. It's on slide 7. How is this relevant to MSCAIF proposal for excellence impact implementation? Is that what you want to show?
Yes.
Okay, so...
Are we changing slides now to excellence?
No.
Okay, so we have a sharing.
Now it changed, yeah.
Now it changed. Okay, yeah. So there's a delay.
Okay.
There's a delay.
Okay.
Okay, so the average 3 sections while we're waiting for the delay. Nothing new there. So let's look at each section one at a time. I'm just going to start with excellence. I'm going to throw at you what you will see in the template in terms of requirements. And let's see if we can highlight the key places where all of the advice you've heard fits directly in. So what's in excellence? They're asking for a quality and credibility of your project. Specifically, they want to see a method. And as John and Gareth mentioned, openness can make your methodology more collaborative, more open, transparent, it's more reproducible. A lot of these are ethical issues. We also mentioned, Gareth mentioned the code of conduct. This is where if you take these principles and make them governing principles to your methodology design, you can win points. We have direct evidence now of, because Marie Curie is so competitive, that applicants are being punished with small amounts for not mentioning, not showing awareness of the researcher's code of conduct. That's not something intuitively one might have guessed coming for the first time into Marie Curie application. So open science, all of the aspects of open science can directly make your methodology more competitive, more excellent, and then give you a very good groundwork to discuss impact later. What else are they discussing? Discussing the quality and appropriateness of your training as an applicant, and the transfer of skills and transfer of results, both from you to the host, from the host to you, and also setting you up for a career. What are the keywords there that one can use open science to beef up your application? Here we're talking about new skills, big data. Open science is explicitly mentioned in the template now, so one has to deal with it. Research integrity, as Gareth mentioned. Research integrity in itself, you could be really space efficient and show awareness of what is important in the code of conduct, and how are you going to use openness and transparency and traceability as a method as a way of designing a better research methodology, but also addressing the needs and requirements on the side of research integrity. They're also talking about transferable skills, and here we have a new emerging opportunity for a skill set that you could add to your tool belt, if you like. Here we're talking about IPR, transfer of the knowledge, of the results, and of the outputs, and possibly doing that through secondments in the private sector, or at least outside of academia. Now here you have an opportunity and you have a challenge. We're talking for 15 minutes about disclosure, and releasing all of your results. Here is a potential conflict. What happens if you want to use some of the results, exploit them commercially? Now, if the obvious conflict can also become an opportunity. If one knows how the two feed off each other and complement each other, that directly gets you evaluation points in a positive way. So it's important to know both skill sets and exactly where they collide and exactly where they augment each other. The other two sections in excellence are quality of supervision, potential to reach professional maturity, and these are areas where really openness doesn't explicitly feed in, or at least we don't have sufficient evidence to show you how it might do that. So let's move on to the next part, solutions. Now that we identified the places in this section of the proposal, what can we throw at you? Again, these are not exhaustive. We are limited in time, but we do invite you to come back to the clinic, present your project to us with your outputs, and then we can hopefully point you to more customized solutions. But generally speaking, what are we trying to say? Use a virtual research environment, a VRE. If you've never come across this.
Sorry, Ivo, we are not seeing it. Can you go to the right slides? We missed the slides before. It's not advancing. You will have to do it manually.
Okay. So I'm just wondering.
I think then we can share the slides with everybody.
We'll definitely.
We can make them available.
Apologies for the technical. Are we seeing something now? Can I change the slides like this?
Yeah.
Okay.
If you change by hand like that, I think we can see.
Okay. Let's go to solutions. Maybe
Thanks.
This is better. We'll definitely share these slides with you. The source of the advice is at the bottom of the slides, and you can trace it through the link. Again, we can. We're more than happy to advise you based on your project. The main message here is using virtual research environments. What are they, and what do they do? Virtual research environments, they're basically online platforms that allow you to collaborate, perform some of the work online, and it's different platforms exist with different functionalities for different disciplines. The question is to find the simple one that works both for you and for your research project. The main idea is that your whole process is verifiable, it can be traced back, and ultimately by incorporating a VRE in your method design and method execution, you can improve the reproducibility of your results and outputs. What else can we do? So the questions here to ask yourself are: does my research question offer opportunities to learn new skills? This is an important part of the application. You have to be explicit about it. So why not use this as an opportunity? If the research question allows to learn a new data science methodology, data mining, text data mining, why not count that as a new skill set? Another question to ask yourself: is replication and reproducibility relevant to your discipline? I hope so. It's a bedrock of research. So how can you spin that into a positive, even though it's supposed to be already a prerequisite for your research design? Well, as Gareth mentioned, make your data fair. And that stands for findable, accessible, interoperable, and reusable. What we're advising candidates now is not just to make the data fair, but make the collection of their research outputs fair. So that goes way beyond data. And I think Gareth also described to you an average research life cycle and the collection of outputs that might produce. And it goes from basic notes, negative results, data, software code. Then you have the research papers. Then you may have educational resources. So all of those are outputs, and all of those you could have a strategy for making them findable, accessible, interoperable, and reusable. And saying so in a short and compact text can get you points. We have evidence for that. Another space-efficient way to show awareness on the issue in this section is to cite peer-reviewed studies that discuss the reproducibility crisis. Show awareness that this is an issue, and that at least your method design is somehow ensuring against that happening, your project suffering from lack of reproducibility, or at least optimizing it. If you're lucky, there may be a study out there that's in your field. So far, we know psychology and cancer biology, and others are coming through. So the relevance there for your field, for your discipline, could be quite high. Another way to pick up easy points, and Gareth touched on this, is just refer to the European Code of Conduct of Research. Have a quick read. What are the main points, and which of those points you can integrate in your research method design? It's a very easy way to lose points. It's a very easy way to pick up points. We're running out of time. I'm going to speed through, but again, we'll share the slides with you for reuse. In the next section, in impact, what can we do to pick up points? Let's see what they're asking for first. They're asking for enhancing the future career prospects, and more specifically, training. How is that training going to impact the career? They're asking for exploitation of dissemination of results, and frequently these are soft skills that John also touched on. We don't get trained into openness. We don't get trained into passing our publications outside of the academic sphere. So these are soft skills that one has to show appetite for, and some kind of strategy for learning them and putting them into action, so that your papers or outputs, your research outputs, reach targets outside of academia as much as practical, as much as the research project allows. And they're also asking for communicating to different target audiences. This includes public, creating awareness of your issue. Why is your research important, and how is it going to touch the world outside of the academic sphere? So that's the requirements. What can we practically do? Again, these are not non-exhaustive suggestions, and the list can go on and on. And the real work here is done only if we get together on a face-to-face sessions through the clinic. But some of the suggestions: publish all your outputs as openly as practical, in synergy with IPR issues. Don't put in peril and risk any commercialization of results. That serves nobody. Use persistent identifiers for your outputs. DOI is a persistent identifier. Others exist out there too. And also specify targeted journals when you write your proposal. That always picks up questions, and if those targeted journals happen to be open, so much the better. Gareth mentioned to you alternative metrics. Again, designing a strategy around maximum openly published outputs and the societal attention on each of those outputs as measured by outmetrics. That is a good, simple performance indicator to kind of keep your exploitation dissemination strategy on some kind of track. The keyword here is outputs, and again, this goes back to what John mentioned as a shift of mindset. It's important that when one writes these applications, one at least shows awareness that the value of the project is more than just the papers you're about to publish through peer review. There is so much more value out there, and if you have a strategy for capturing the impact of each of those outputs, that's what the evaluator is like. Another recommendation is to align all of the soft skills that you are about to gather through your host and argue that they will put you in the best place for tenure, not just according to the criteria of today, like bibliometrics, but also the tenure criteria of the future, like how much time do you spend on communicating your result? How much time do you spend on transferring published papers down the exploitation pathway, either to academia or outside of academia? And in future, those things will matter, and they will be part of your evaluation. So it's important in Marie Curie to argue that the collection of those soft skills really puts you on track for future tenure according to future criteria. Last but not least, do a little bit of homework on where are the conflicts and the synergies between opening up all of your research process and retaining some of it for commercial exploitation. It is something that the funders care about, and it is something that you should be aware of. And if it sounds daunting and if it sounds scary, there is a quick way to get a running start on it. The gentleman that has coined the term open innovation has also, in 15 pages, given us a summary of where exactly are the synergies and the conflicts between open science by default and traditional IPR strategies. So you don't have to reinvent the wheel, just show awareness that you can read horizontally around your discipline. And the last point here is, and I think Gareth reiterated that several times, by making your research open by default as much as practical, you set yourself up for a really effective communication strategy. I think it was John also mentioned earlier, how are we supposed to be taken in a credible way if nobody can access the results that we publish? And that's a very important point, and it has been very much on the agenda in the context of research conduct lately. So do show awareness of it. You can cite some of these, show awareness by citing key documents as footnotes. And that's a space-efficient way to show that you know what you're talking about. The last section in an average application is really the implementation, and it's just showing that you know how to administer a research project. I'm not going to spend much time on it. The take-home messages are that if you are in data-intensive research, that's going to require some intensive resources and time. So don't underestimate what it takes to write the metadata, to publish your negative results, to make your code reusable by somebody who doesn't work in your group. So the evaluators will punish you if you're a little bit naive and you promise a lot of openness, but you don't put the resources behind it. So do be aware of that. And in most institutions, people, libraries, and research support staff can advise you on how you do that credibly. Right. So all that to say that in this webinar, we focus only on the first part, on access to the research, but hopefully we've convinced you that it's a first step of a very important pipeline of transferring all of your research from the lab and into society and achieving greater societal impact, something that is very difficult to measure, but it will not go away in future if you are looking to build a research group around and found yourself independent. So before we go to Q&A, and we are running very late, apologize for that, I'm only going to flash some of the evaluation comments that we have gathered over the last 3 years with respect to open science. Some of them are positive, some of them are negative, but at least it gives you a quick flavor of how open science contributes to the whole application throughout each of the sections, rather than just in one single paragraph, as one might expect from the start. So it's important to be integrative and think holistically of the whole project, and what are all of the outputs of that project, and what are the variety of strategies and infrastructures and tools that you could use to augment that. So I think we could try and have 2 or 3 minutes of questions, if that's realistic. Do send us the questions anyway through the chat box, and we'll try and organize and categorize them post-event, and hopefully give you some kind of meaningful results as much as practical. I cannot see the Q&A at the moment, but if we have 1 or 2 questions.
Yeah, Ivo, we've got some questions on our end here, which we can use to get things started. I wanted to, I guess, get things started by bouncing off what Gareth was saying at the end about having all of these different outputs and metrics and things on research applications. So you can make your life a hell of a lot easier by keeping a website. If you don't have a personal webpage yet to sort of showcase your work and who you are, the things which you're interested in the future, then you're putting yourself at a severe disadvantage. It's incredibly easy and incredibly cheap these days to create a website, and you can basically showcase all of your research through this. You can put things like the main themes of research which you're interested in, links to all of your various outputs, and keep constant updates of all of the metrics should you wish on there. So for example, I keep a list of all of my publications on there, and I include the alt metric score and the patient count, and deliberately don't include the journal name or impact factor as well. And that sort of serves as an example how junior researchers can move away from this archaic, crappy proxy system towards, what they're displaying being the things which matter most on an article or individual level. As well as that, there's a service called Impact Story, which I strongly recommend everyone to check out, where you can integrate your ORCID profile, which should hopefully contain all of your research outputs, and it provides a fun little way of getting recognition for all of that, as well as tracking the how your research has been disseminated across the web. It's extremely powerful, extremely simple, and brilliant for early career researchers.
Great, thanks, John. Maybe the last one before we wrap up. Gareth, I see there's a lot of appetite on research integrity. What can we add more on research integrity in terms of meaningful integration in a research project?
Yeah, I would say that for many people they're not fully clear what exactly research integrity is. They are very clear what integrity is, but research integrity is of course a lot more specific. I would refer everybody to look at the ALEA Code of Conduct, and again I'll put a link in after here. And this is a very short, very in my opinion, very good, very concise code to help you on integrity, and I'll give some of the main examples from this code. So for instance, they follow 4 key principles, and then they give examples of good practices in this. The first principle is reliability, ensuring the quality of research reflected in the design, the methodology, the analysis, and the use of resources. They focus on the second principle of honesty, So in developing, undertaking, reviewing, reporting, and communicating research in a transparent, fair, full, and unbiased way. The third principle is respect for colleagues, research participants, society, ecosystems, cultural heritage, and the environment. And the fourth main principle is accountability for the research from idea to publication, for its management and organization, for training, supervision, mentoring, and for its wider impacts. And again, in the LA Code, they have actual examples of all of these principles. They also have three key, how will I call these, unprinciples of research misconduct. And those three are fabrication, so making up results and recording them as if they were real. The second unprinciple is falsification, so manipulating research materials, equipment, processes, changing, omitting, or suppressing data or results without justification. And the final unprinciple is plagiarism, so using other people's work and ideas without giving proper credit or violating the rights of others. In some cases, even self-plagiarizing, which I think I see people referring to this. So I would refer to the LA Code. You can read up all of these and you can look at the good practices for it. I'm not sure if Ivo's there.
Ivo, did we lose it?
It looks like it.
I think we lost him. Yes. So.
Asleep.
So, Gareth, John, maybe you want to wrap up?
Mm-hmm. Go, Gareth, you can go first.
I'm just going to say that I think, together we all need to move towards an open science friendly environment. And I think the steps are now being put in place and that we need to follow through. And the community needs to support this, early career researchers and senior researchers and institutions and funders. That's the only way we're all going to do this together.
Mm-hmm. Cool. I guess all I would say is that, open science, it doesn't exist in science and good scientific practices. You're doing open science by default, and then with ultimate intention. I believe that a lot of junior researchers do not think that they have any sort of power or say in any of this. And that's the system sort of crushing it down out of them. And the best advice I can give is reach out, see what networks exist, see what power you do have, and see where it takes you. And you never know, you could change the world. Go for it.
That's a good statement for ending it. Maya, if you want to come back and join us.
Hi. It was very interesting discussion. We reached our limited time, as I see it. Thanks for the people for posting the questions. We will continue this discussion. MCAA is organizing also the Open Science session at ESOF in Toulouse on the 12th of July. And follow us on YouTube, Twitter, and Facebook account, where we all the time announce our exciting webinars. Fernanda?
Well, so I think it's up to me to say goodbye and thank you for staying with us for so long. It was a very interesting webinar, and I will send you then the slides that you didn't have the occasion to follow through. There was some technical problem, and well, I think that's it. Did we forget anything?
Just one thing, because Ivo's connection dropped, but he did say that he'll also send information on the webinar from tomorrow via email.
Oh, yes. Yes, and for further questions, do contact Foster. They do a great job and they can help you with your proposal. Okay, I think that's it. Bye.
Bye.
Thanks, everyone. Bye.
Bye, everyone. Have a nice day.